Hello everybody and welcome back. We're going to continue taking a look at the year 2001 Pascal paper. That's the grade 9 Pascal paper. We're on question 22. In the diagram, AB and BD are the radii of a circle with center B. Okay. The area of sector ABD is 2 pi. So the area of this whole figure is 2 pi. And we're also told that that's 1/8 of the area of the circle. The area of the shaded region is, so this is a common question. I see it pop up, every couple years or so on the Pascal, Cayley, the Fermat. Sometimes you see it on a Euclid. And we have a sector here, and we should be able to figure out the area of the whole thing. In this case, we were just given it. And then either we take out a piece here, or more often we take out a triangle, like this, and we're asked what's the remaining area, this shaded area here. So we have the area of the whole thing is 2 pi. Now we need to figure out the area of this triangle right here. So then we can subtract that off, and it'll give us the shaded region. So the shaded region is the sector or section of the circle minus the triangle. I think it was triangle ABC. Yep. So we have a nice little right angle here. That might help us. And we're told things like AB and BD are the radii of a circle, and B is the center. So we know that the sector is 1/8. It's a 1/8 section, so it's 1/8 the area of the circle. We're also told that the sector is 2 pi in terms of its area. Well, 1/8 of the area of a circle. Well, what's the area of a circle? It's pi r squared. So 2 pi is going to be r squared over 8 times pi. Divide both sides by pi, you're left with 2 is equal to r squared over 8. Multiply 8 on both sides, we have 16 is equal to r squared. So r is equal to 4. So that's nice and helpful. So we know r is equal to 4. But, I mean, we have this right angle here, so we very clearly have AC as the height and BC as the base of this triangle. And we know the area of the sector. That was great. Now we know the length AB. Whether or not that's useful is remaining to be seen. If we could figure out AC and BC, we'd be all set. Because we have the sector, then we'd have the area of the triangle, we can get the area of the shaded region. So we know AB is equal to 4. And we know it's 1/2 base times height is the area of the triangle. But as I just pointed out, the base is going to be BC, and the height is going to be AC. So if we could just figure out those, we'd be golden. Now we're given that the sector ABD is 1/8 the area of the circle. And that will give us a clue as to what the angle at B is. So the angle at B is just going to be 1/8 the total angle of the circle, which is 1/8 360. So I'm going to let that angle be theta. So we know that theta is 1/8 the total angle of the circle. You can say 360 degrees or you can say 2 pi radians, however you want to do it. I'm going to keep it in degrees right now because it's the grade 9 contest. If you really wanted to, you could also say 400 gradians, but no one uses gradians. So we can see it's going to be a 45-degree angle. So 45 degrees, well, that's pretty special. That means that BC is equal to AC. Okay. So what I'm going to do is I'm going to let AC, which is equal to BC, equal to X. And by the Pythagorean theorem, because we have a right angle right here, ABC, it's got a right angle at C, we know that AB squared is equal to AC squared plus CB squared. That's x squared plus x squared. And we know what AB is. It's 4. So 4 squared, that's 16. That's 2x squared. So that tells me x squared is going to be equal to 8. And you can work it out with your calculator. That x is going to be 2 root 2, or that's about 2.828, I believe. So we know what x is. Anyway, so we can figure out, as I said, shaded region is equal to the sector of the circle minus the triangle. And that's 2 pi minus 1/2 base times height. Well, there's the base. There's the height. We know that they're equal to 8. So we didn't even need to work out 2 root 2. So 2 pi minus 1/2 8. That's going to be 2 pi minus 4. Okay? So 2 pi minus 4, that should be our final answer of what the shaded area is. We did section of the circle minus the triangle that we've cut out, and we get 2 pi minus 4. Notice really quickly that we also have 2 pi minus 8 as a possible answer. That's if you forgot, I occasionally forget, to do the 1/2 when you're doing the area of the triangle formula. So that's there to trip you up. And 2 pi minus 2, I guess that's if you applied an extra half. But we're going to go with our answer of A, 2 pi minus 4. And we'll bubble that in. Or in this case, just give it a little circle. So as always, thank you guys so much for watching. Feel free to throw a like on the video if you're liking the 2001 Pascal contest so far. And either way, please join me for the question number 23, which we'll take care of in the next video.